Welcome to tonight's webinar. My name is Ned Bowman. For those of you not familiar with me, I'm the outreach coordinator with Great Basin Bird Observatory. We are a nonprofit bird research organization based in Reno, Nevada, and we conduct research throughout the state of Nevada and the Eastern Sierra and surrounding areas a bit into Arizona. And tonight's webinar is part of our winter lecture series. We are rescheduling Frank's talk from earlier in the year when he was laid up in the airport due to weather. So fortunately, we were able to get him rescheduled and we have him here tonight. You can see more about our upcoming webinars and other events on our website, gbbo.org, as well as by looking up Great Basin Bird Observatory on Instagram and Facebook. We have a presentation coming up on Monday, March 4th from Guillermo Costoya, who is a PhD student at the University of Nevada, Reno, and he's going to be talking about Western fence lizards. So we've got more info on that on the website, but we are excited to hear his talk. And before I turn this over to Frank, I just want to mention to everyone that tonight's webinar is going to be recorded and available on the GBBO YouTube channel. And if anyone has any questions, feel free to type them into the chat, but we're going to hold all the questions until the end, and hopefully we've got a bit of time to chat with Frank after the presentation. So without further ado, I would like to introduce Frank Fogarty, who has done a bunch of research throughout Nevada in some of these montane riparian systems, which is a very neat habitat, and I'm excited to hear what he's got to tell us. So without further ado, I am going to shut up and turn it over to Frank.
Great, thanks, Ned. And thanks anybody who has joined us after the rescheduling. I got caught in the crazy airline delays with those Supermax planes and stuck on the other side of the country. So I'm glad I was able to talk with you all tonight and to talk about these montane riparian birds and their habitats in the Great Basin, which is a system that I've worked with for a while and that continues to fascinate me. So just a little bit about myself and how I got to talking about this stuff. I was lucky to start working on birds in the Great Basin in 2013 when I started collecting point count and vegetation data in some of the mountain ranges that I'm going to talk about today, mostly in central Nevada. And I really fell in love with this system. This is one of those riparian areas with both wet meadow here that you can see and woody riparian behind it. I can turn that laser pointer on for that. And this eventually led to an opportunity to do some PhD work on this same system at the University of California, Davis. So I got to keep working out there and analyzing data, both from this area I'm going to talk about tonight, and then also from a lot of the Western Great Basins, the edge of the Western Great Basin, and a few other spots around the Great Basin. And right now I'm currently an assistant professor of applied avian ecology at the Department of Wildlife at Cal Poly Humboldt, which is what we now call Humboldt State University. We've changed our name and I'm just starting to get it right now. So here at Cal Poly Humboldt, my interest in the projects I'm working on have broadened. I'm now working on birds outside the Great Basin, which is something I wasn't sure I would ever say about myself, but I'm still really fascinated by the system. I'm still actively involved in some collaborations on projects out there and looking forward to getting some additional ones up and running to follow up on some of the questions that I'll talk about tonight. So I'm giving a talk for an organization called the Great Basin Bird Observatory. I probably don't need to spend a lot of time defining what the Great Basin is to everybody here. But I just want to point out there's a number of different ways that you can actually define the border of the Great Basin. It's more or less bounded by the Sierra Nevada to the west, the Columbia Plateau to the north, the Wasatch Range just east of Salt Lake to the east. Most people use those boundaries there. It's kind of the southern boundary and the northwestern boundary that get a little bit fuzzy. I usually like to use kind of the boundary of the Mojave Desert as thinking about the edge of the basin because that has the most similarity to the systems I'm talking about in this sagebrush sea dominated area. But however we define it, it's somewhere around a 500,000 square kilometers. It's arid to semi-arid. A lot of the Great Basin can be classified as desert. Some of the more upland areas get a little bit more precip than that. And a defining feature that I'm sure, again, a lot of folks here know is the basin and range topography. You can see it really well on this figure here. All of these north-south ranges running across the Great Basin in parallel. And that gives you the cool opportunity to study these ranges that are close by to each other, but are separate systems separated by these big, broad valleys. And I'm going to talk about a number of those today. And we're talking about birds. So I will point out that there's somewhere around 140 breeding land birds that are highly associated with or dependent on breeding in the Great Basin in some way. And the majority of those are associated with riparian areas. I'll come back to that in a few minutes. So I've thrown the word riparian around a few times today. I should probably define that. Riparian just refers to areas that are either adjacent to or influenced in some way by flowing water. So that can be alongside springs, creeks, on rivers. And we often define these riparian areas, especially those of us who work on animals like birds, by their unique vegetation. So the riparian zone is that zone that has this unique vegetation. And that's really exemplified in places like the Great Basin, where that contrast between these areas with more water and the drier uplands can be really stark. And you can see that here in this canyon. This is in the Tequima Mountains, Meadow Canyon, and you got all this riparian vegetation along the edge of the road here. In the background, you got a lot of willows. And then that very quickly, as soon as you move about a meter or so up in elevation, you go from all that riparian to much more open space, rocky soil, and sage, rabbit brush dominated system. So really stark contrast there. And I also wanted to answer the question, what's so special about these areas in the Great Basin? Why am I talking about riparian areas today? So you're probably aware this is a really arid system. We may often think of the Great Basin as being a desert. And actually, these riparian systems are far less than 1% of the total land area. So they're a scarce aspect of the landscape. I mentioned there's 140 bird species that are breeding in the Great Basin. Despite riparian areas being less than 1% of that total area, more than half of all those 140 bird species are strongly associated with these riparian areas. So it's a disproportionately important type of land cover if we're thinking about the diversity of birds in the Great Basin, because so many species are dependent on these riparian areas. And another reason that riparian areas are interesting in the Great Basin is that they have a lot of natural fragmentation. Now, I'll talk a little bit more about fragmentation in the latter half of my talk, but that essentially refers to habitat being broken up into pieces and having long edges and things like that, rather than being in just one large block. A lot of studies that have looked at fragmentation in birds and in other animals have really centered on habitats that have been fragmented or broken up by human activities, people doing things to previously intact chunks of habitat and breaking them up into smaller pieces. And there's been a lot less work looking at systems that have a lot of natural fragmentation. And that natural fragmentation often occurs when you have these really scarce land cover types like riparian in the Great Basin. So I'll show you some maps in a few minutes, but if you look at aerial maps or you walk around on the ground and think about this, these riparian areas are often not in a big circular patch. They're often in these long, slender, broken up chunks with lots of edge, naturally fragmented, which makes them a cool system to study for this. That said, I don't want to downplay the fact that humans have also had a detrimental effect on riparian areas, especially over the last few centuries in the Great Basin. So even though these systems are highly naturally fragmented, they still do experience some anthropogenic fragmentation as well. Some of the main culprits there, grazing can be an issue, both cattle just eating those tasty riparian plants and actually physically removing or degrading some of that riparian habitat. Cattle can also contribute to erosion and stream incision. You can see some really bad stream incision here with the really steep banks there on this creek in this image. Other direct things humans do, water diversion, which just reduces the total amount of water available for these riparian plant communities and the animals that depend on them. Both subsurface and surface water diversion there can have that effect. And in some cases, also the removal of beaver from a lot of these places may have really impacted stream incision like we see here. And that stream incision often just wipes out the riparian communities. Because what happens here is any water that's down in the soil or groundwater, once the stream channel has dropped like this, it drops way lower than the surrounding uplands. And basically you just have an almost instantaneous switch from the stream bed to dry uplands. You no longer have the water table close enough to the surface to support that riparian community sprawling out from the stream channel. So lots of reasons why this system has become so fragmented. But I'm talking about birds today, so I should get back to at least talking a little bit about these montane riparian bird communities. The first thing I want to point out is that there are no endemic riparian bird species in the Great Basin, meaning there's no bird species that don't occur anywhere else in the world in this system. All these species that I'm talking about occur elsewhere. They occur outside the Great Basin, often both to the east and the west and the north. They often also occur in very different habitats compared to the Great Basin, often in quite wetter habitats outside the Great Basin and in less fragmented habitats as well. And I think that's true certainly for all three of these species that are shown here. So as a result of that information, I'm not going to focus on any specific species of conservation concern or listed species of any kind, but on this unique community or these unique communities. I think we should always refer to them as being plural, and you'll see why in a few minutes, but these communities of birds in riparian systems in the Great Basin. So even if these species occur elsewhere, again, you can find large-eye buntings and house wrens breeding pretty close to me over in coastal California where I live. Red-naped sapsuckers can occur farther east and farther south outside of the Great Basin. And none of these species I'm going to talk about are on the endangered species list. However, the assemblages of birds that I'm talking about are unique and I would argue valuable part of the Great Basin ecosystem. The fact that a lot of these are non-desert species, in fact, I'd characterize most of these as really not species we think of as desert species, but they're surviving in these small pockets of riparian area that are just scattered out in this larger arid landscape. It's really a fascinating adaptation that these birds have. And I think from a conservation standpoint, it's possible that these populations have some genetic variability that allows them to survive in what is often the harshest landscape that the species uses compared to some other places that they live. And if that's the case, it may be useful to preserve and to conserve and to continue these populations that are occurring in these small riparian areas in the Great Basin because they may have some useful characteristics and useful adaptations that if we're facing a warmer and a drier future where more land cover elsewhere is changing outside the Great Basin, those could be useful adaptations for these birds. That's a lot of speculation there. We don't really know. No one has really studied that in these birds, but I just want to highlight the fact that I think these communities are unique and are worth considering for conservation. So where am I talking about? I've been talking mostly about the Great Basin so far. For today's talk, I'm going to be focusing in on one of the areas that I've worked the most, which are these mountain ranges in central Nevada. They're actually pretty close to the geographic center of Nevada. You can see that little inset up there at the top, and then this is the blown up version here. I'm talking about 4 mountain ranges here. So these are the Shoshone Mountains over here that are a little bit cut out by the inset. The Toyabis here, very high mountain range with Arc Dome down here, kind of about 2/3 the way down. And then the Tequima Mountains, and then the Monitor Range furthest to the east. So all the data I'm going to be talking about comes from these mountain ranges and comes from 24 canyons. They're represented largely by these black squiggles here. So showing you there's a pretty good spread of where these locations are. And I'm going to bring this up, the fact that I'm focusing on these mountains here, because the Great Basin is not a monolith. We can't think of every part of the Great Basin as functioning the same for birds. Birds do different things and use habitats differently within different parts of the entire Great Basin. We're looking at the northern Great Basin, the central, the west. They do different things. If folks are interested in that concept, I did some work with a colleague, Martha Zillig, on this, and she has some cool publications demonstrating that even the habitat associations of a lot of these widespread bird species are not the same across these different areas. So maybe take that as an asterisk that I'm really focusing on these classic basin and range systems that occur in most of the middle of Nevada. But if you get over to the Eastern Sierra around Mono Lake, there could be very different things happening there. And I would just point out that all these sites were within about 100 miles of each other. I think maybe the farthest canyons apart I'm talking about were a little over 100 miles apart. Even so, we see a lot of variation in the size of these riparian areas that we're looking at. We see a lot of variation also in the bird communities that are present. The smallest canyons that we surveyed in terms of riparian communities just had a single species. We had some canyons where we went and surveyed multiple points and only found one riparian bird species. In a given year, the largest communities would be somewhere up north of 14, 15 species. And then talking about some long-term data today, so stretching over 15 years, including some of it going back to before I joined this project, most of these canyons, if you're aggregating it across those 15 years, have anywhere between about 7 and high 20s bird species out of the community of a total of 33 occurring riparian bird species. So a lot of variation there in what we see in each community. Which leads me to this question here about whether these bird communities are predictable. Are there ways that we can predict who's going to be present, where, and in what community based on any kind of environmental factors? Because I think this is an important first step if we're studying these birds, is to understand if there's any sort of pattern there to what's going on. And I talked about those range sizes, or the extent of those ranges a moment ago. So that variation, how many birds we see in those canyons. And unfortunately, that is actually a little bit of an oversimplification. So nature rarely makes things very easy on us. And so we need to really think about whether these communities are stable across both space and time. By space, I mean just nearby. So if we're looking at adjacent canyons that seem similar, do we expect to see similar bird communities between them? And then the stability across time is, if I am doing a point count today, if I do it a year from now during the breeding season, or 3 years from now, do I expect to see similar communities there, especially if those riparian areas aren't changing really rapidly? And maybe not surprisingly, the answer to this question, whether they're predictable or whether they're static over time, is not really to both questions. Both in time and space, these communities show a lot of variability, and this kind of poses a challenge to studying them that I'm going to talk about a little bit. Maybe this makes a little bit of intuitive sense, especially if you're considering communities across space. So if you're looking at different canyons or different mountain ranges, the riparian habitat is likely not going to be identical even across any of them. And not all species have the same needs there. So you're going to see some variation in what species are present. You can also have species that are just more rare than other species. So maybe there's some structure that we expect to see there. For example, in this illustration here, warbling vireo and dusky flycatcher in the center, I would say, are among our more numerous riparian species. We frequently see these in a lot of canyons that have riparian vegetation. Western flycatcher, rest in peace, Cordilleran flycatcher. It's now been relumped with pack slope, but this tends to be a much more uncommon species, maybe some specific habitat associations. We only find it in a fraction of the total canyons that we look at. And then maybe even rarer than that, black-crowned night herons are not a species that we encounter in a lot of canyons, but they do occur as part of this community. So maybe there's some structure there as we get from rarer to more common species. And so to think a little bit more about this predictability of the communities and how it affects our ability to understand them, I'm going to introduce a very technical ecology concept called beta diversity. Which is just a fancy ecology term that says how similar or how different are two communities. And this isn't just for birds, we use this across plants and all kinds of other animals. And so this is a question that we can't just answer by counting how many species are in each community. You can't just make a list of all the species that you found, because two canyons could have the same number of species. If we consider these to be two communities here, one on the left, one on the right, say they were from neighboring canyons. If you count, there's 4 images in each one. If that represents 4 species in each one, just counting how many species are present doesn't give us the full picture there. Because if you look closely here, there's only one species in common. Pelagiolite bunting is the only one that's shared between these two. So you could say 75% of the species are unique between these two communities. So there is a substantial difference in the beta diversity there. And that might really change our interpretation of what's going on in these sites or in these canyons. I'm going to talk about 2 main processes that that drive beta diversity, two of the main explanations for what type of differences we're getting between these communities. And they're important because they affect our ability to actually say things, at least in a predictable manner about these systems. The first one we're talking about is called nestedness. And so nestedness basically just suggests that there's predictability to who is present in a community, and that is based on the size of the community, how many species that are present. So you have some species that are going to be present in nearly all communities. So you've got these common species, they're widespread, maybe they're a bit more generalist and able to hack it even in the roughest conditions. They're going to be the only species you really expect to see in really small communities. And then as those communities get larger, it represents maybe that there's more resources there are more niches that are opened up, and in a predictable way, you'll start to add additional species, and the rarest species are only going to be present in the largest communities. You can almost think about this as like nested Russian dolls or something like that. And so here's a little example of that. If we think of these as three different communities here, if we start over here at the right, let's say this is a very small community present on the landscape with that lazuli bunting and house wren and broad-tailed hummingbird. I've just chosen these photos as examples, although all three of these are fairly widespread species. This isn't a perfect illustration of what this would look like. But in this example here, if we bump up to a community with 4 species or with 5 species, we still see those original 3 core species always there in those larger communities, and we're adding additional species there. What we don't see are really tiny communities that look really different if nestedness is driving this process. It'd be weird to see a small community that's just black-crowned night herons and western flycatchers and none of these other birds. That would be strange in a nested framework. And again, maybe it's because these guys are the most adaptable, and as we get up here to these larger communities, it represents the most specialized bird species. But there's another option. We can also think about beta diversity as turnover. So the turnover is essentially lacking this pattern. You get differences between communities that are independent of community size, and there's not really a straightforward, predictable way that this works. So if we, again, start with our 5 species community here on the left, if the system's driven by turnover, this is what a 4 species community might look like. So here, we only have 1 shared species or 2 shared species across the 2. We've replaced these other 2 in the larger community. So it's not nested to that same extent, and your smallest community might look something like this. So this would not be a nested system here where our smallest community actually doesn't share any species with our largest community there. There's something else going on here, and it's not that nice, predictable subset that we saw. When I'm doing this in person and talking about this, I usually like to ask for a show of hands, let the audience vote for which process that you think might matter more in our Great Basin montane systems, that nestedness or turnover. I think if I tried to figure out how to do that on Zoom, I might be here for another half hour just trying to figure out how to do the hand raise things, or kind of be chaos if we had people turn on their mics. So I'll just give away the punchline because I'm doing this on Zoom. I can give you a moment if you want to make your guess, but it's turnover. So it's the second one here, and we have data suggesting that this is really the process that drives what's going on in these systems. So this was surprising to us. We certainly expected to see some of that turnover-driven diversity there, but it was surprising how much of that seemed to explain what was going on, and the implications that there's a lot of randomness in what is present in these individual communities. So this is work that was led by a colleague, Jian Yan, that I collaborated on comparing turnover and nestedness. So here, this is spatial results. So the higher these little box plots are up on the y-axis here, the more of that beta diversity is explained by that process. And here you can see that both at the point count site level and at the canyon, we saw a lot more of that beta diversity explained by turnover compared to nestedness, what I just said there. We got a lot of changes. These communities were changing across between visits, across time. We saw those changes in what communities were present there, and a lot of it seemed to be explained by turnover, not by nestedness. And so that's spatial. We saw the same effect, although a little bit more muted for temporal. So again, if we're looking at this across time, this is If I went to survey a spot in 2014, and then I came back in 2016 and surveyed the same spot, our results suggested that there's a good chance that we're going to see different species in that exact same spot in a subsequent year or multiple years down the road. And that seems to be independent of any stark land cover changes. This is not that those sites all burned or there was a dramatic change in grazing patterns or things like that. The sites and their vegetation seem relatively stable, especially just looking across a few years at this. Yet we still saw a significant amount of change in these communities. And again, here comparing turnover to nestedness, we see a lot more temporal, especially at the point count level, at a single individual site, maybe about the scale of territories for individual birds. So this is suggesting that there's a lot of change going on both across time and space. And it's fairly random here. There's not that predictable pattern of small communities being predictable and dominated by these generalist species and you needing larger communities to accommodate specialists, which was really interesting to us. And I think a real surprise to everybody involved in this work and maybe a bit of a challenge. So it's really, I would say, yeah, a new wrinkle in our understanding of birds in the Great Basin. We knew this wasn't going to be totally static, that we'd see the same bird species everywhere or always in similar systems, that there'd be some perfect way of predicting things, but we didn't expect to see as much turnover as we were seeing in both time and space. And like any good scientist, we came out of this with more questions than we went in with. So we still don't entirely know what's going on here. I think there's room to explore some of the mechanisms for what's happening. But I'll throw out a couple potential explanations here. So one is that we're dealing primarily with fairly small communities here. So when you talk about there being house wrens and there being McGillivray's warblers and lazuli buntings, especially at the level of an individual point count, that often is just 1 to maybe 3 pairs of birds present there. So 1 or 2 individual birds exiting or entering a community at a site could actually cause a lot of difference here, especially when we're looking at the point level. When we're scaling up to the whole canyon, those effects weren't quite as large there. And that could be because they're buffered a little bit more there. You can have a change in how many lazuli buntings are in your canyon, but as long as you at least have some, they're still considered present there. So one possibility is that, yeah, there's some noise here because these communities are so small. This could also be related to what we frequently call founder effects, which are related to competition. So this is the idea that the founder effect is when migration occurs, whoever happens to get there first and set up territory is at an automatic advantage to defend that territory from other birds that arrive. There's a little bit of randomness as to whether a warbling vireo or a yellow warbler or a McGillivray's warbler shows up and gets there first, or what are the first 2 or 3 birds that arrive. And then that founder effect of just who randomly got down there first and was able to defend it might affect these competitions or these communities in some way. Maybe there's only so many birds that can squeeze in, and who shows up first matters. And then maybe the least satisfying explanation of all of these, but one we always have to consider, is that it could even be purely random and not driven by competition there. This is a harsh environment, even though there are these riparian systems. Overall, they're patchy areas. They have limited riparian area. There's limited resources available there. Annual survival may be low for these birds. All the species we're talking about are long distance migrants. Migration is really tough and hazardous. And so it could be that there's a whole bunch of things affecting the individual survival of these birds and their membership in the community. And it could just end up random year to year, that the environment is harsh enough that competing with other birds isn't really playing into things. There aren't actually enough birds out there to have the most fit species occupy every patch. And it could just be random who ends up at each location each year. But I think the big important takeaway from all of this is the composition of a community at a single place and time doesn't necessarily tell us the full story about the actual species that use that area. This is a really dynamic system, and we need to keep that in mind. And this is a real challenge to studying birds in the Great Basin, is that you can get so much variation and change across time and space. So I think keep that in mind as a complication that maybe inspired some of the other stuff I'm going to talk about here, and also makes it a challenge as I kind of move into talking a little bit more about some of the habitat and how it affects birds there. So we've seen these communities tend to do change across time. I want to talk a little bit now about the differences in those riparian areas in these canyons that the birds are using and how that might affect the bird communities. So not all of these riparian communities are equal. Big surprise there. Even if we think about montane areas just in one part of the Great Basin, just in these 4 mountain ranges, you still get differences in size and shape, in fragmentation, in the condition of vegetation, in the elevation, both at the low and the end point of the riparian area, the steepness of the grade in these canyons, what plant communities are present. Are they dominated by water birch or willow or a mixture of both? Is there an aspen overstory? That's a lot to consider. And in fact, that's probably not possible to easily measure all those things. And that might be a lifetime's work to consider all of those different factors that make these canyons variable. So I'm going to take a shortcut here and focus primarily on the 2 most classic ways of thinking about habitat and how it affects communities. And that's just really simply thinking about area and fragmentation. So area is just in a canyon, how much riparian habitat is there present? What's the total acreage of habitat that's present there? And then fragmentation, I've thrown this word around a few times. This is just how dispersed or broken up that habitat is. How long are the edges around individual patches? Are they nice round circles that are quite large and there's few of them? If there are more than one patch, how far apart are they from each other? How long and squiggly are they? All different ways that we can measure fragmentation. And this brings in some kind of classic theory in ecology. This dates back to the mid-20th century that suggests that as you get more habitat, you get more species present. So habitat area and species richness are correlated positively. And then as that habitat becomes more fragmented, you're going to lose species richness. Even if area stays about the same, if it's fragmented more, you'll expect to see fewer species there. So they have opposite effects on species richness. And this is kind of something that's been tested a bajillion times. There's a lot of data and support for it out there. And scientists, of course, love to disagree with things. So about 10 years ago, we saw some, I guess it's not that recent now, but contention that, maybe fragmentation actually doesn't matter much, which sort of sent a lot of scientists who'd worked on this for decades kind of up the wall, this idea. But Lenore Farrig, starting in 2013, proposed this idea of a habitat amount hypothesis, and basically said that fragmentation doesn't matter at all. It's only the amount of habitat. It doesn't matter how it's configured or laid out or fragmented, just area is what mattered. And her explanation here for how so many people got this wrong is that a lot of the ways that we measure fragmentation end up being really tightly correlated with area. And so what we're doing is just measuring area twice, 2 different ways. And that you really have to make sure that you disentangle the interaction between area and fragmentation to actually be able to effectively look at whether or not fragmentation affects communities. So I'll circle back to that at the end. I will tell you that we are looking at an independent measure of fragmentation. So one that isn't connected with area and you can measure it independently. But this is something a lot of people haven't done before. Okay, and here's a NAEP imagery. So this is satellite imagery of one part of one of our canyons. This is Barrett Canyon in the Shoshone Mountains. And those bright pink areas are not bright pink in real life. This was the result of a lot of painstaking hand delineation of these riparian areas. So I went in and hand drew polygons around all those riparian areas based on zooming in on this satellite imagery and then also ground truthing this in our experience on the ground. Here, just to make it easy, I've colored them bright pink. But a couple things I want to point out, if we think of that blue line as roughly the boundaries of the canyon, at least from a bird's perspective that's living in the canyon bottoms, those pink areas are a small percentage of the total landscape. They're probably less than 1%, similar to what I said for the whole Great Basin there. So they're a small amount of the total habitat area, and they're quite fragmented. I think this is a really great illustration of what fragmentation can look like. They're not all in one big square, right? It's that pink area. It's not a big circle. Some of these patches are spread quite far apart from each other. They're weird shapes. They have long edges. These are all things that are characteristic of fragmentation. I can guarantee the system was affected in some ways by humans. If you went back 300 years, it would likely not be as fragmented as it is now, but it also wouldn't have been one giant block. 300 years ago. So there is some anthropogenic fragmentation here. It's really hard to disentangle how much of that is caused by humans versus natural. But again, these are naturally fragmented systems. And I'm actually not attempting to disentangle those two. So when I'm talking about fragmentation throughout, I'm really just talking about the reality of how we measure it on the ground, regardless of how that occurred. Okay, which brings me to the next question that I want to talk about. Again, keep in mind that idea that these communities have a lot of change in who is present there. But now I'm just talking about the size of these communities. And I wanted to know, kind of getting back to that classic idea in ecology, whether or not our bird communities in the Central Great Basin were affected by the area of their habitat and its fragmentation. So does the total amount of riparian area and how fragmented it is affect how many birds are present in a canyon? This is Stewart Canyon in the Toyabe Mountains, kind of the southern Toyabe Mountains, one of our biggest in area, and also one of the least fragmented riparian canyons that I'm going to talk about. So I'm going to show a little bit of results here. This is a lot less scary than it looks here. Basically, the way that you read this posterior plot is that if any of these horizontal bars here don't cross this dashed line, that means they're important. That means we have significant evidence that that's an important factor in affecting community size. So here, there's only two that are important. All these other ones cross over that dashed line. You can ignore the intercept there. That just conclusively tells us that there are a positive number of birds in these canyons, which is a completely useless result. I probably should have just removed that there. But the real interesting one here is this second one. So this is the total amount of woody riparian habitat. We split out wet meadows from woody riparian. So woody riparian is willow, rose, water birch, aspen, cottonwood, any of these larger perennial woody riparian plants, whereas wet meadows are mostly sedges and grasses and things without any taller veg. So because this is out to the right of the line, that means that it had a positive effect. So and a substantially positive effect. So the more riparian area you have, the more riparian bird species you have in a canyon. Probably not surprising, this follows along that paradigm in ecology. More habitat area equals more species. I do want to point out here, this is our measure of fragmentation. NLSI just stands for the Normalized Landscape Shape Index. This is just a fancy metric for measuring fragmentation and one that's independent of area. So we were careful to select one that wasn't going to be biased by the amount of habitat area. And here it overlaps zero. It turns out that it was not an important predictor of community size. It did not seem that riparian fragmentation mattered for these systems. And then these three down here at the bottom are just quadratics to see if the relationships had funny shapes, weird curvature or peaks in the middle. And again, none of those came out as being important. So the one big takeaway here is that, at least in our system, it seems like only the amount of habitat area matters. I do want to mention an important caveat before I jump to the next slide here. Fragmentation, both natural and anthropogenic, can also cause losses in riparian area, and those losses in riparian area and fragmentations are often intertwined. So even though I'm saying we're using independent measures there, it's actually really hard to do one without causing some of the other. And so we need to keep that in mind here, that we're trying to measure these independently here, but they do often go act in tandem with each other. That said, you can have the same amount of area with different amounts of fragmentation, the same amount of fragmentation in different areas. So there is variation there. Just want to point out, though, that they almost always increase together to some extent. And I also would be remiss if I didn't mention that there can be some tipping points here. Really small patches of riparian are probably the ones that are most at risk of disappearing altogether because they have so much edge around them, because they probably have so little water to begin with. And those interactions may change, those tipping points may change in a warmer and a drier future. So want to keep that in mind. And then the second big takeaway from this was that there really seemed to be a bit of an inflection or a tipping point here. So a canyon only needs about 25 hectares of woody riparian area, a little bit more than that to really be at the max community size. That's what our models projected there. And doubling that, tripling that, we had canyons up to 100 hectares of riparian area. You don't get much difference there. A little bit less variability in the model's confidence, but you basically are at the max community size, the entire community present. And then on the flip side, as you go down as you lose area below 25. And we had canyons all the way down to less than 1 hectare of riparian area. That does occur in the Great Basin. You lose species really quickly. So it falls off really quickly, but it plateaus maybe somewhere between around 25, 30 hectares of riparian area. And that's really interesting. If we want to manage for large communities, if we want to manage for these unique communities, we might want to focus on these intermediate sized canyons. That might be really important, and maybe focusing on just the total amount of area rather than trying to make sure it's all contiguous in one patch. Maybe that doesn't matter so much. An interesting little aside here as well. This was for 15 years of data. We also did this for just 1 year, 2013. The results are nearly identical for just 1 year of data. I could flip these graphs back and forth and they would look nearly identical. We also got almost the same effect looking at all bird species, not just riparian bird species. So even though we see these variations and this turnover in who's present in communities, this result for the size of the community seems to be pretty consistent across time. Then finally, the last piece of our analysis was examining some potential future losses of riparian. So we created these scenarios where each individual patch contracted by 1 meter or by 5 meters, so losing a strip around the edge of that size. We think that's how patches will shrink in the future. It's not just going to be cut in half or something. It probably will contract all the way around from all the sides. So we did that on our images. We then calculated the new amounts of fragmentation in the riparian area, fed those into our model to predict some outcomes there. And probably not surprisingly, the canyons that really were at risk there were those moderate sized canyons, around 25, 30 hectares of riparian area. Just this small contraction, even just 1 meter, lost 7% all the way up to 22% of the riparian communities there. So again, these may be our targets if we want to do management to maximize the species that are present. Okay, so just a couple take-home messages here at the end, and then I can answer some questions. First of all, as a reminder, we got lots of turnover in these systems. So that's a real challenge. We don't fully understand the mechanisms that drive that turnover. Some of it may just be random, but it's there. This poses a real challenge both for studying those communities, so just figuring out how to actually study them in an effective way, and also for monitoring them over time. How do you effectively monitor communities to see if they're being impacted by climate change or by something else when there's so much change seemingly random on an annual basis? So I think this is still a challenge that we need to rise and meet and think about ways to overcome. We did find support for that habitat amount hypothesis. So this idea that's kind of upended 70 years of ecology, this idea that it's just habitat. At least in our system, fragmentation doesn't seem to be associated with the size of these communities with species richness. Again, I'll throw out that caveat. We should keep in mind nature is always really dynamic. These patterns could shift in the future, especially if there's changes in climate. We really don't know what's going to happen to the climate in the Great Basin over the next few decades. And so we probably don't want to completely disregard fragmentation. Should at least still consider it, but this is, I think, useful information potentially for management. And the cool thing here is that this pattern really seems to hold up, again, consistently across time and across space. So despite those first results that I showed you about how much the individual species change in these canyons, if we just think something about the entire community and how big the community is, it seems like there are some fairly predictable controls on that community size, even if the specific species that are there are hard to predict. So that comes full circle to my earlier point that I made about focusing on communities rather than individual species, in part because this may be the better way to think about this system. This is kind of a unique system. And if we want to consider the most diversity in the most places, maybe we should really focus on targeting those moderately sized riparian areas. Again, those ones that are kind of in the middle or a little bit below average, what we're looking at. Those larger systems, those larger canyons really seem buffered. If you have 75 or 100 hectares of riparian area, you're probably not going to lose any species in that canyon, even with that 5-meter contraction that might happen in the future. And those really small canyons have such small communities to begin with that there's not much really to gain there. So maybe that should be our at least in the short run, our management target, if this is an important thing that we would like to conserve. Okay, so Oh, and there, thank you everybody for joining and watching my talk, supporting a virtual talk tonight. Got to say thank you to a bunch of my collaborators. I think this is everyone who was a co-author on some of the work that I talked about tonight. My contact info is down there, and certainly the organizations, Joint Fire Science Program, Southwest Climate Adaptation Science Center, that funded much of this work. Did my PhD work at UC Davis, which included some of what I talked about here. And as I mentioned, I'm now at Cal Poly Humboldt. Great. Anyone have any questions?
Awesome, Frank. That was very interesting. Thanks for sharing all that. So, don't see any questions coming in just yet, but we'll give folks a minute to digest, and everyone feel free to type into the chat box, the Q&A, raise your hand if you have anything you want to ask Frank. But yeah, interesting about that fragmentation, a little counterintuitive, huh?
Yeah, I will say there's more, it's kind of a debate in the literature now, and it's probably system specific. There probably are certainly systems where it matters a lot, but at least in our system with that natural fragmentation, we really found no evidence there. And in fact, a slight little bit of evidence that more fragmentation actually increases species richness. It wasn't significant, strongly overlapping zero there, but it actually was even pushing in the opposite direction of the paradigm there.
Yeah, very interesting. I mean, edge habitat, I guess these aren't really big chunks of habitat to begin with, so a lot of these birds are probably into the whole open space next to the dense cover. That might be something.
Yep. I think that's a big part of it. Yeah, only the largest patches are probably big enough that an individual bird's territory doesn't extend all the way over. So almost all of these birds have some of their territory, the edge of their territory, that are in contact with non-habitat or not riparian areas. Oh, the chat box is disabled apparently.
Yeah, I saw that, and I'm trying to figure out how I
Yeah.
can
Okay.
enable that. But they were able to
It
type
looks
in
like the
Q&A, so
Q&A. Yeah. Thank you,
yeah.
Kristen. Yeah, so I think maybe if you click the Q&A button, you might be able to type something.
Yeah, chat should be enabled now, but I don't see an enable chat, but I've allowed. Oh, there we go. Thanks, Kristen. So if anyone else has any questions, you can type into the chat or the Q&A, but it looks like we don't have any questions. Oh, here we go. We have one from Larry. If can you read the Q&As, Frank, or do you want me to prompt you?
Yeah, I can see it there.
Oh, okay, cool.
I can just, do you think that the fact that fragmentation doesn't affect species richness much has to do with most species being migratory? Would we see more impact in places where more birds are resident? That's a good question. Yeah, I think I really briefly mentioned that we looked at this for all bird species as well, and we got a really similar effect there. I was mostly focusing on the riparian, but we actually ran this analysis for all bird species. There certainly are some non-migratory smaller land birds present in these systems, but the vast majority of these birds are migratory. So it's a little bit of a hypothetical, I think, there as to thinking about how this would be affected by resident species year round. But that's an interesting idea of whether this could have a different effect in winter for birds that are trying to overwinter in these zones. But certainly at least the riparian species, nearly all, if not all of them in most of these communities are migratory. And I should say that this is mostly, we don't have things like larger bodied species like raptors and upland species like sage grouse and things that have really large home ranges that we're analyzing in these data. This is data taken from these canyon systems where we're mostly looking at woodpeckers, hummingbirds, and songbirds for the most part.
Yeah, it makes sense that these riparian systems would be pretty rich in resources and provide everything that a songbird would need in a small territory in the summer, whereas in the winter they would likely need a bigger chunk of habitat to provide all those resources. But
Yeah, and just a challenge for some of these species. I think it gets cold at 7,000 feet out there in the middle of Nevada. Yeah.
yep. Cool. Well, unless we have any more questions, I think that will conclude our presentation tonight.
Great. Thanks everyone again for coming.
Cool. And thank you, Frank. We appreciate that. Just remind everyone you can check us out on gbbo.org and on our Facebook and Instagram. We are Great Basin Bird Observatory. And we will post this to our YouTube channel as well, where we have a number of other previously recorded webinars. We are Great Basin Bird Observatory on YouTube as well.
Oh, there's one more question that just made
Last
it
minute
there.
question from Rose.
Have you looked at the Nevada Breeding Bird Atlas to compare your riparian bird species with those found in the 2000s? I have anecdotally looked at a few. There were a few survey sites that did overlap with where we were working, although a lot of these spots are quite remote and out of the way of some of those Breeding Bird Atlas locations. These data also go back to 2003, so not too much different than the beginning of the Breeding Bird Atlas. So the results I was showing you all are, yeah, 2003 to 2018, somewhere around there. So maybe not a huge change there. There's also a little bit of a difference in the methods there. It's hard to get the granular level data that we were looking for, especially for the point level, out of at least what's publicly available from the Breeding Bird Atlas. But that's a neat idea and something to consider for changes over time as well.
Cool. Hopefully that answers your question, Rose. Nice. All right. Well, thank you everyone for coming, and thank you again, Frank. We appreciate you rescheduling. That was very interesting. So
Great.
go ahead
Thank
and
you.
sign us off. Thanks everyone, and have a good night.